All right, today is December 2nd. Sorry I'm not here. My baby has an ear infection, so I have to go home. We're spending another day on Graphs of Polynomials again today, and you can see your assignment is quite short, so please make sure you do it right and check your answers, that sort of thing. It's based on what we did last week, which was we started doing some sketching of functions. And so if you remember from last week, we had things like we can find the zeros really easily. We can find the leading term, and then we can check to see, does it bounce or does it pass through or does it slide through that zero? And so we're going to apply that same knowledge today. I am going to go kind of fast, so please remember you can pause this video and rewind if you need to listen to it again. So first, I want to find the leading term, LT, leading term. And if you look at this in factored form pretty easily, we can see we have a negative 1/2, we have an x being squared, and we have an x to the first power, which would give me a leading term of negative 1/2 x cubed. And if you remember from last week, those are odd arms, crazy arms, and they're decreasing. So one starts up high on the left and low on the right. Once we know where the arrows begin and end, then we can find the zeros. So from here, looking at our factors, the zeros, we get our x equals 2, and that has a multiplicity of 2. And here we have x equals negative 3 with the multiplicity of 1. And I can make a quick little sketch. Let's see, 2, there's 2, and at negative 3, 1, 2, negative 3. And I know that my arrow starts up high on the left and it's going to end low on the right. And I can, let's see, I'm going to hit negative 3 first. And I'm going to pass right through that one since it's a multiplicity of 1. And then the next zero I'm going to hit is 2. And it has a multiplicity of 2, which means we're bouncing. Turn around, and I had to bounce off that 0. So again, bouncing really just means that if you look really closely, just right around 2, our graph, the shape of it is really just a parabola. It's something being squared, and so it has a parabolic shape. And here with a multiplicity of 1, if we're looking right around that 0, sort of zoom in, you can see that it passes through, it almost looks like a line. So it's linear, passes through like a line. So that is what we did yesterday. Now, today we're talking about where is our function greater than 0 and where is our function less than 0. And we've done this before, but now we have to apply multiplicity to that. So we want to know where is our function above the axis and where is it below the axis. F of x refers to y values. So we're wondering, hey, where are the y values greater than 0? Where are they positive? Or where are the y values less than 0 or negative? Okay, and we can do that a number of ways. So I think you can do it graphically like this. Your book tells you not to do it graphically. I don't care how you do it. You can use a calculator too. So I'll do both. Again, you can pause if you need to if I'm going too fast. Example 1, part A, find the y-intercept. Ooh, y-intercept. Part B, find the x-intercepts. Okay, easy. C, find the intervals of x, the intervals of x, where f of x is greater than 0 and where f of x is less than 0. So lots of answers here. And again, your book tells you do not sketch the graphs, but again, I don't really care how you do it. So I guess I'll show you a couple of different ways to do that. So the first and probably most basic way is just to do a sign chart. So I'm going to do the sign chart method first. Sign chart is a great method, and this is probably the method that the book wants you to use. And it's definitely a method you're going to see again in calculus, so it's good to know. The first thing they wanted us to do is find the y-intercept. Well, how do you find a y-intercept? Well, it's when x is equal to 0. So we can plug that in pretty easily. Plugging in 0 for the x, 0 minus 1, And 0 plus 2, quantity squared. 0 minus 1 is -1. And 2 squared is 4. So we get -4, which is the y-intercept. So that's interesting to know. All right. Let's see, find the x-intercepts. Okay, so the x-intercepts we know come from these bubbles. So the x-intercepts, we get x equals 1 and x equals -2. So those are the x-intercepts. And I'm going to use those x-intercepts on my sign chart. They are critical values. So I have a -2 and a +1. Basically, your sign chart, this is just the real number line, which really just represents the x-axis. And what I can do then is I can plug in some values. So you're going to do some test values. And if you wanted to use your calculator, you could. But it's really easy to just plug it in since we're in factored form. So some easy values between -2 and 1, you could test with a 0, which is about right there. We know that. We already did that, which I think is why they said find the y-intercept. When you plug in a 0 into your function, we got -4 for the y value. Well, that is where our function value is less than 0. So in this region, all of these values are going to have negative y values. And that's what's interesting about these x-intercepts. That's where the only places where change can happen. Everything between -2 and 1, whatever number you plug in for x, is going to give you a y value that's negative. A number to the right of 1, I could test like, I don't know, x equals 2 or 3 or 4 or 5, lots of values you can plug in there. And I'm just going to plug that into my function, plugging in a 2 for the x. I would have 2 minus 1 is 1. And here 2 plus 2 is 4. Squared is 16. So I get y equals 16, which is a positive value. So everything in this region has a positive result. Everything to the right of 1 is positive. And then over here, we want to plug in another value. So again, I can go and just plug in numbers. Anything to the left of -2, -3, -4, -5, -6. I'm just going to try -3. X equals -3. So I'm plugging in a -3 here. -3 minus 1 is -4. And -3 plus 2 is -1. But you square that, it becomes +1. And so we get -4 for the y values. I'm not interested in the number. I'm only interested in whether it's positive or negative, whether our function, our y values are greater than 0 or positive, or whether our y values are less than 0 or negative. That's really all I care about. So you really just have to think about, is it signs? What the sign is. Is it going to be a positive or negative result? So in order to answer this question, we want to know where f of x is greater than 0. F of x is greater than 0, and we want to know the intervals of x. So to be greater than 0 means to be positive, and that's this interval. When x is greater than 1. So this is using inequality notation. So these are x values greater than 1. All of these values would give us positive results. I'm pretty sure your book uses that notation. Yeah. But also, if you wanted to, you could use 1 to infinity as another way to answer that. All right, f of x is less than 0 or negative. All of these regions are where our y values are negative. And so we can say when x is less than -2 and not and, or, I don't know what your word. I think the book uses or. When x is between -2 and 1. So we could say x is greater than -2 or less than 1. And if you wanted to use inequality notation, not inequality, sorry, interval notation, we would say negative infinity to negative 2. And we join together with negative 2 to 1. So you can use inequality notation as well. Inequality or interval notation. I don't care which. You need to know both. Now, the book actually told us not to do things graphically, but since we have all of this information and it's in factored form, and you guys are very smart, then we can easily make a graph. I mean, really, which is what we have been doing. We know that at 1 and negative 2, these are our zeros. And I know that at my leading term would be x cubed. So we would start low on the left and then high on the right. At negative 2, we have multiplicity 2, so we're going to bounce there. And then at 1, we pass straight through. And so we have our graph. And so we can see here, all of these are our output values. The y output values are all negative in this region to the left of negative 2. Between negative 2 and 1, our graph, again, is below the axis, which means the y values are all negative land. All of these are negative output values between negative 2 and 1. And then here, our graph is above the x-axis, meaning the y values are all positive for everything to the right of 1. And again, we're going to get the same answers as we do here. So you can do it either way. You can use a sign chart and just plug in numbers, or we can graph it. And for me, I really like this, but either way. I'll do it both ways with the calculator this last time. Or I'm not going to do it both ways. I'm just going to do it graphically. All right, y-intercept is the first thing we need to find. Y-intercept occurs when x is equal to 0. So we have f of 0, 0 squared, 0 minus 3 cubed, and 0 plus 2, which 0 times anything is going to be 0. So our y-intercept is 0. We have a few x-intercepts. We have x equals 0 with a multiplicity of 2. We have x equals 3 with a multiplicity of 3. That's a slide. And then we have x equals negative 2, and that has a multiplicity of 1. So if I were to think about trying to sketch this, I guess I'd need the leading term, which would be x squared times x cubed times x to the first, which is x to the 5/6. Even arms, and it's positive, so our arrows are going to be arms up arrows. You have graphing calculators. You can absolutely do this on your graphing calculator. So I have x equals 0 as an x-intercept. I have 3 as an x-intercept, and I have negative 2 as an x-intercept. I'm going to go ahead and just graph that in my calculator. So I'm going to y equals, and I'm typing it in. Oops, that's supposed to be a cube. And then x plus 2. So I've typed it into my calculator into y equals, and I'm going to graph it. Kind of interesting. You can see the little slide there, and we've got a bounce. Arms up, so I start up high, and I pass right through negative 2. I have to turn around, and I'm going to hit the 0. That's going to have a bounce to it. And then I have to slide, because it's multiplicity 3. Slide to the right, so it gets a little slide. So there's the graph. And the reason I'm using my calculator is, so you can see, we could do a sign chart as well. Just boil it down to just the values. And then we're just looking for where are we positive or negative. And so looking at this picture, my graph is above, so everything to the left of negative 2 would be positive values for y. Here our graph is below the axis, so between 0 and negative 2, we have negative y values. Between 0 and 3, again, we're below. Our graph is below the axis, so negative y values. And here we have positive because we're above. You can test that if you wanted to. Using your calculator, I can use trace. Hit trace, and I want a number to the left of negative 2, like negative 3. So you can just type in negative 3, and oh, look at that. That is 1944. That is a very, very large positive value, which means everything to the left would have positive y values. Between negative 2 and 0, I could try negative 1. So I'm going to type in negative 1, and you can see we get a negative output. Everything between negative 2 and 0 would give us that negative output value. Between 0 and 3 is a number like 1 or 2 or 2.5. So if I tried 1, again, I'm getting a negative output value. Everything between 0 and 3 would give us a negative result. And then I could try something like 4. And if I plug in a 4, again, I get positive 96, a positive output value. So to answer the question, where is f of x greater than 0? F of x is greater than 0 when? So greater than 0 means positive. So we're looking for our positive intervals. When x is less than negative 2, or, so that's all of this, everything less than negative 2, or when x is greater than 3, we also get positive. So x is greater than 3. If you wanted to write negative infinity to negative 2, union 3 to infinity, you could do that as well. Let's see, f of x is less than 0. Less than 0 means negative. When, here we get negative outputs. F of x, remember, is the same as y. So y values are negative. When x is between negative 2 and 0. So x is greater than negative 2 and less than 0. Or when x is between 0 and 3. Greater than 0 and less than 3. If you wanted to write negative 2 to 0, union 0 to 3, you could do that as well. I think that's fine. It's so much tighter. How come I had this in 2 intervals and I couldn't just say from negative 2 to 3? At 0, we're equal to 0, and we're not interested in that solution. We only want to be less than 0, so we have to separate it into 2 different solution intervals. All right, so this shouldn't take you guys long at all. That's it for me for notes. Use your calculators, graph things. I think it's great to apply the knowledge we learned from last week with pass, bounce, and slide for a multiplicity of 3. Really good to just keep that fresh in your brain. So there you go. Have a go. Make sure you turn this in. You should be able to finish before you leave, no problems. See you later, guys.